Hello students, welcome to AriserTalent. I am your teacher Arpita Sharma. Okay, so we will start a new chapter today. Okay, so this chapter is very familiar, triangles. Okay, as the name says, triangle. Okay, so what does triangle mean? Triangle is simply a figure that consists of triangle, three angles. Tri is three and angle is an angle. Okay, so I know that you all my students know definitely about triangles. So what we are going to do in this chapter, because we have studied triangle from our last 4 to 5 classes like 9th, 8th, 7th, 6th. So what's new in this? We will be studying some properties of triangle, some interesting things about triangle. Okay, so let's start. Similarity. Okay, so have you all are familiar with this sign? This sign you know as the sign of congruency. You all know what does congruency mean. For just a recall, I am gonna tell you what the congruency is. Two similar figures in shape and size like this. These two bottles are exactly same in shape and in size also. So what we used to call these kind of figures in our previous classes, we used to call them congruent. Then they are congruent, exactly same. In our local language, we can say this exactly same. That means congruent. Okay. Then what is similarity? Okay. We all use this Surf Excel or any washing powder, you use it. Okay. So sometime your mother buy 1 kg or 5 kg, sometime let it be 1 kg, and sometime she'll bought 1 kg or half kg. Okay, so the packing is same, that cover is same. Now the size of this packet and this packet is not same, but as you can see, the shape of this packet and this packet is also same. They are proportional. Okay, sides are even proportional. You can have many more examples from your day-to-day life, and you know you are buying some sets of 3 in different size, like in bags. You do that, then we find them in the same shape but different sizes. Okay, so this is a day-to-day example of similarity. So we can say that if shape same and if size is same, we will be calling it congruent. But if shape is same but size is not same but proportional, then we will call it a similar figure, and if that figure is a triangle, then we'll call it similar triangle, right? Okay, so I assume you understood it. I know my students are very intelligent. So, moving next. Any two line segments. This is about two line segment. Now, this line AB and this line is something like PQ. I've told you about congruency, I've told you about similarity. Now look at this. You can simply look at this and you can say that, ma'am, yes, the shape of AB and PQ is same. There is no other way to draw a line, it's always same. So, two lines are always what? Same or similar, but they are not congruent. If PQ, let's suppose 5 centimeters, it's not 5 centimeters, but I am telling you to assume, and it's say like 7 centimeters. Okay, but what if I'm saying that this is also 7 centimeter and this is also, if AB and PQ are two different lines and they are having same length, then only those lines can be congruent, but two lines are always similar. You have no doubt about that. Okay. So, lines part is done. So, moving to the next part, student. Circles. Now, I am having a circle of radius 5 centimeter and circle of radius 10 centimeters. Okay. Now, if I am taking any two circles, look at those two figures. They are similar. You can tell it by just looking at it. Okay. So, those both are what? Similar, but are they congruent? If the radius of this circle is equals to the radius of another given circle is equal. Okay, if the radius of these two circles are equal, then only these circles are congruent, but they are always similar. Okay, so till now we have known that if we are talking about line, they are always similar, but congruent. When it will be congruent? When the length of line will be same. In case of circle, they will be always similar. Okay. So, what you conclude? That they may or may not be congruent, but they are always similar. This is an important point. Okay. So, we have written this, any two circles are similar but not necessarily congruent. They may be congruent but not necessarily. They are congruent if their radius or diameter are equal. Okay, this is one, and note it. Now, the previous one, any two line segments again are always similar, but they need not to be congruent. They are congruent if their lengths are equal. So, if lengths are equal, they are congruent, but if lengths are not equal, then they are similar. Whether the length is equal or unequal, they are always similar. Okay. Moving forward about any two square. Any two squares are also similar. So you are like, what are telling us, ma'am, this is also similar, this is also similar. That what is, we can say that similar sometimes and not similar sometimes. We will be going there also. But first look at this. Any two squares are similar. Okay. What are squares? Squares are quadrilaterals whose all the four sides are of equal length. Okay, so if this is 5 centimeter, this is 5 centimeter, this is 5 centimeter, and this is 5 centimeter in a quadrilateral ABCD, then this quadrilateral will be assumed as or will be called as square. That means if all the sides of a quadrilateral are equal, then it's called as what? Square. Okay, so if I am going to draw a square of 10 centimeter, that will be something like this. Okay. Now, these squares are always similar but not always need to be congruent. So, we just have written it in this manner. Any two we have these two squares that are similar. Now, next, any two equilateral triangle. Now, coming to triangle, which is actually our chapter is, you need to know that we are having triangle, right angle triangle, then isosceles triangle, and then equilateral triangle. Now, in equilateral triangle, you are having all sides equal. Okay. So, if you are having an equilateral triangle, only equilateral triangle is always what? Similar. If you are having an equilateral triangle, I have told you what equilateral triangle does actually mean. If these are two, this is one equilateral triangle, this is the second equilateral triangle, let us assume of 3 centimeter, and this is B of, let's assume 5 centimeter, 5 centimeters. Okay, we are repeating this again and again. Now 3, so it will be automatically 3. That's why it's an equilateral triangle. That will be 5. That will be 5. Okay, so if we are looking at equilateral triangle, whether it will be 1000 centimeter or 1000 of meters or kilometers, but if it's an equilateral triangle, then it will be always similar, but need not always be congruent. Okay. So what's next? Let's see. Similar polygons. Now, what are polygons? If we are having any closed figure in which we are having more than 2 sides, then what we call it? A polygon. Now, understand this. I am drawing a triangle here, a square, a rectangle here. We have talked about these figures so many times. Okay, now this triangle is a polygon, this square is a polygon, and this rectangle is also a polygon. Triangle is just a polygon with least number of sides. If we draw any two lines in any manner, it cannot be closed, and polygon is a closed figure, okay, made up of sides, okay. So, it's saying that two polygons are said to be similar when we will say that these two polygons are similar to each other if their corresponding angles are equal. Their corresponding angles are equal means if I am having a polygon like this, okay, and again I am having a polygon like this. I am naming it like A, B, C, D, E, F, and I am naming it like P, Q, R, S, T, U. Now it's saying their corresponding angles are equal. What does that mean, corresponding angles are equal? That means angle A will be equals to angle P, angle B will be equals to angle Q, angle C will be equals to angle R, angle D will be equals to angle S, then angle E will be equals to angle T, and angle F will be equals to angle U. If it follow, these two polygons follow this particular way, then we may consider the second point, because number one, first point is clear. Now the second point about the length of sides, the lengths of their corresponding sides. Okay, if they are equal, then the polygon will be congruent, but if they are proportional, okay, if they are proportional, then it will be similar. From the first point, we can see that from this point, it may be congruent or it may be similar, but if it follows the second one, then it is obviously congruent and similar, okay. Sorry, it won't be congruent. From the second line, we understood that it won't be congruent, but it will be similar, okay. Now, from the above definition, it follows that angle at A equals to angle at P. This is all the written things I have make you understood you here, okay students. Now, again, AB equals to PQ, sorry, AB divided by PQ, because the ratios are same. So, this line AB will be, if we will take the ratio of AB with this corresponding line of PQRST U polygon, then that will be equals to your BC line divided by your QR line, then CD upon RS, and this is CD and this is RS, this is DE, and this is what? Corresponding line is ST and EF by UT and AF by PU. So, the ratios of the corresponding sides will be equal in this case. Okay, students? Note this, I am going to rub that. Students, I've told you that look at this figure, look at this triangle, look at this and look at that, and you'll find out that this is similar and this is not. So, let me confuse you. I'm having these two textbooks here. Now, assuming that its color is black and its color is also black, they are similar, right? Aren't they? No, they are not. Why? Because if you look carefully, this side and this side are same, but you see the margin here, this side, this particular side is not equals to this side. So, it's not having that proportion. It's looking like a similar one, but they are not actually similar. So, it's being very different when you talk like it's similar to this, it's similar to this in your daily routine language. But you when you enters into mathematics, you're going to see things with the proportions, okay? Not with the only looking at it. Okay, so I am telling you this and that, we will be going to prove them also. We'll be having some theorems, some fun of theorems and blah and blah and blah. Okay. Okay. Moving to the next. If two polygons A, B, C, D, E and P, Q, R, S, T are similar, we write A, B, C, D, E. Now, this is what? This is sign of similarity. Like, okay, this was the sign of congruency. Now, this is the sign of similarity. So, if I have to write that this particular polygon is congruent to this particular polygon, which is I have named like A, B, C, D, E, F and P, Q, R, S, T, U. Now, I am saying that right, this and this polygon are congruent, I'll use this sign, but if I have to say that this and this polygon are similar, then I have to use this particular sign. Okay, here I will mention the polygon, this, here I will mention this polygon, okay, and will use this sign for similarity. Okay, this is a small thing. Okay, students, so now we are having a figure also here in which we have mentioned the dimensions, the sides and the angles also. In polygon, you have to be sure that each angle is equal. We have read this in our this here, angle A equals to angle P, angle B equals to angle at Q. So, we have just shown it here that this is 130, this is 100, this is 90, this is 90. So, all these angles are similar to, exactly similar to these angles first. Now, if we will talk about the sides here, okay. So, let us see this 3 centimeter upon 4.5 centimeter should be equals to 4 centimeter above 4 centimeter divided by 6 centimeter. Now, that will give you 30 by 45. Okay. Now, this will be 2 and 3, right. Now, this will be 15 and this will be 9. Okay. 3 centimeter, 4.5 centimeter, 4 centimeter and 6 centimeter, right? So, okay, we have done it wrong. That will be by 6. Okay, now again that will be 2 and that will be 3. So, this is 2 by 3 and this is also 2 by 3. So, we can see that ratio of DE and ST is equals to ratio of DC and SR. Similarly, we can here prove that this particular QR with this ratio, okay, is also same. So, corresponding sides, if we are taking ratios of corresponding sides, they are going to be equal in each and every case. Okay, let's try us on this CB and RQ. Now, CB is what? 3 centimeter and RB is what? 4.5 centimeter. Again this, okay. So, this will be again what? 2 by 3, right? This is 4 and this is 6, again 4 by 6, again 2 by 3, okay. Now, this EA and TP, this is 3.2 and this is 4.8. Now, EA upon TP, okay. So, we will calculate it, okay. That will be cut out by 16. So, it will be 2, it will be 3, again 2 by 3, okay. So, if you have to check whether two polygons are same or not and you are given with the sides, okay. So, what will you do? You will simply take ratios, okay, and the ratios, if the ratios are same, then this is similar. If the ratios are not same, then this is not similar, okay. I am going to rub this. Okay, students. Now, what's next? Similar triangle and their properties. Okay, so whenever we study something, let it be not only maths, let it be physics, chemistry and blah and blah and blah. Okay, whenever we are going to study something, we always use the property, because if we are going to study something, that we have to know it well, na. So, you have to know the properties of that particular thing. So, we are studying triangle and in class 10th, we are focused on similar triangle, not congruent but similar triangle. So, we need to know about their properties and we will check whether the properties are actually working or not. Okay. Now, the definition, we have definitely covered it in our slides, but because our whole chapter is on the triangle, so we have to have a other look on that also. Two triangles are said to be similar if their corresponding angles are equal. 1. Corresponding sides are proportional. 2. If corresponding sides are proportional but also equal, then this type of similar triangle is actually a congruent one. But if they are proportional, then this is only similar, not congruent. Okay. So, something can be both congruent and similar, but it is not compulsory to be congruent for a similar thing. Okay. It is not compulsory for a similar thing to be congruent. Okay. Now, you have to correct it when I am saying something wrong. You have to tell me that no ma'am, you have not made our concepts like this, you are wrong here. Okay. So, in this particular kind of triangle, similar triangle, what we are having, that if A, B, C and D, E, F are 2, given triangle, then angle A will be equals to angle D, angle B equals to angle E, angle C equals to angle F. If we have given in question that this and this are similar, you are going to do what? You are going to make these particular corresponding angles equal and you're gonna use them, okay, in your question. And AB by DE, that is AB by DE, then BC, this is BC, okay, and EF, that will be equals to AC and DF. Okay, students, write it. Okay, students, so we have covered similar triangles and their property. So what about covering things all and all this? Then when we are going to use them, because we are studying it from first minute of our lecture. So we have covered the properties and we will be discussing some theorems and some questions in our next session. Thank you. Keep watching.